Don Machholz, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 65, for the week of March 31st, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. What's up in the sky this week? As our week begins on Wednesday, March 31st, the moon is bright in the morning sky, rising more than 2 hours after twilight ends. And it rises about an hour later each night, giving us plenty of dark sky time under the evening sky. The moon will be third quarter on Sunday, April 4th. That's when it's half full in the morning sky and you see it in your western sky later in the day. By next Tuesday, it will be about 25% full in the morning sky. The moon passes south of Saturn on April 6th and south of Jupiter on April 7th. There's no bright comets in our sky this week. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, March 31st through Tuesday, April 6th? It all depends upon your location. This week we have 5 zones. All you need to know is your latitude. At 65 degrees north and north of that, you will not see the International Space Station at all. From 42 degrees through 60 degrees north, you can see the International Space Station in the evening sky, but only for the first few days of this week. From 15 through 42 degrees north, the ISS will be in your sky all week long. It will be in your evening sky, sometimes twice per evening. From 40 degrees south to about 15 degrees north, and that's a lot of you, the International Space Station will not be in your sky this week. And from 55 degrees south to 40 degrees south, the ISS will be in your morning sky, sometimes twice per morning. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Now for the astro class. I want to talk for a few minutes about the solar system. There are some basic things to know about the solar system as you get more involved in astronomy. The solar system contains the sun, planets, asteroids, comets, and meteoroids, and dust, lots of dust. The sun is the center of the solar system and contains more than 99% of the mass of the whole solar system. All the other objects orbit around the sun. The planets all go around the sun in the same direction. And seen from above the North Pole, the planets go around the sun in a counterclockwise direction. Asteroids generally do too. Comets are different. They go around the sun in all types of directions. But those that are periodic comets, that is, they come back within 200 years or less, generally go around the sun in the same direction that we do. Are we all in the same plane? That is to say, if the sun were on the middle of a table and the planets going around it, would all the major planets also be on the table, or are some below and some above the table? Well, first of all, the Earth is on the table. We define where the table is. Any planet tilt is in relation to our orbit. Most planets are within 3 degrees of our orbit. Mercury has a tilt of 7 degrees. And the moon, which orbits the Earth, has a tilt of 5 degrees. This helps us to find the planets, the sun, and the moon in our sky. The planets tend to follow the ecliptic, an imaginary line going around the sky. It crosses the equator twice, and it goes as far north as 23.5 degrees north of the equator, and as far south as 23.5 degrees south of the equator. That tilt is caused by the fact that we are tilted 23.5 degrees from the plane of the ecliptic. We're still on the table, but tilted, so that our North Pole is not pointed straight up from the table, and the South Pole is not pointed straight down to the table. So the ecliptic line we see in the sky, or do not see because it is imaginary, the sun follows it exactly. The moon can be up to 5 degrees north or south of it. The planets are typically within a few degrees of the ecliptic too. From the Earth, you'll never see Jupiter in the Big Dipper or in the constellation Cassiopeia, or passing through the Magellanic Clouds in the southern hemisphere. No, they behave themselves and hang out near the ecliptic. The constellations that are the ecliptic, actually background behind the ecliptic, are known as the zodiac constellations. The sun, moon, and planets, as they travel the ecliptic, pass in front of those constellations, and we say, Jupiter is in Sagittarius, or Mars is in Gemini. They are not really in the constellation, they are in front of the constellation. They are close, and the stars of the constellation are very far away from us. There are some people who give importance to the location of the planets when you were born, and that's called astrology. Astrology is not astronomy. Astronomy does not care where the planets were when you were born. Astronomers are much more concerned about where they are tonight. As the year progresses, the sun goes around the sky once. You cannot see what constellation it's in because it's so bright the stars are not visible in the daytime. Actually, it's our atmosphere that is bright, and it is bright because of the sun. We are the third planet from the sun. The closer the planet is to the sun, the faster it travels in miles per second or kilometers per second, and the less time it takes for it to go around the sun. There are 2 planets that have an orbit inside our orbit. They are closer to the sun than we are. They are the planets Mercury and Venus. Because they are inside our orbit, they sometimes pass between the sun and us. Usually they pass just north or south of the sun, but when they go across the face of the sun, as seen from the Earth, that is called a transit. Mercury transits about a dozen times per century, an average of once every 7 or 8 years. Mercury transited the sun in 2016 and 2019. It will next transit in the year 2032. It takes several hours to cross the face of the sun, and everyone who can see the sun, and that's about half the Earth at any one time, can see the transit of the planet. Now, transits of Venus are much more rare. One was in 2004, another one in 2012, and the next one is a long ways away. It will be in the year 2117, followed by one in 2125. The next transit of Venus is 96 years away. And as it approaches, I'll be talking about it on this podcast. It is because Mercury and Venus are close to the Sun that we cannot see them unless we look near the direction of the Sun. If you want to see the planet Mercury, look in the western sky shortly after sunset, or in the morning sky shortly before sunrise. Mercury in its best position will set within 2 hours or less after sunset, or rise only 2 hours or less before sunrise. You will not see Mercury overhead at midnight. The planet Venus makes a wider arc in our sky and is several times brighter than Mercury. It can be seen in the evening after sunset or in the morning before sunrise. Sometimes Venus is called the morning or evening star, but it's not really a star, it's a planet. It is our brightest planet, only the sun and moon are brighter, but it will never be overhead at midnight. The other planets are what are known as the outer planets. They are Mars, Jupiter, Saturn, Uranus, and Neptune. They too travel the ecliptic, and we are sometimes between them and the sun, meaning they rise when the sun sets, are up all night long, and set when the night is over and the sun rises. When they reach that point, it is called opposition, and we are usually as close to them as we will get all year. When Jupiter reaches opposition, that's a big thing, and it happens every 13 months. Astronomers and the general public alike get out and observe Jupiter. Same for Saturn, which comes to opposition every 12.5 months. Meanwhile, for the public, our most popular planet at opposition is Mars, and it comes to opposition every 2.2 years. The last time was last October 2020. The next time will be December 2022. That is when Mars will be at its next opposition. It will be large and up all night long, and people will want to see it. One more thing about planets, and this concerns their physical properties. The first 4 planets are called rocky planets. The last 4 are called the gas planets or the gas giants. Now, that doesn't mean the rocky planets do not have atmospheres. Some do. Nor does that mean the gas giants do not have rock. But one way of looking at them is that the first 4 are rocky and the last 4 are gassy or gaseous. Asteroids are smaller planets, very small, like a meter across, that's 3 feet across, up to 1,000 kilometers, that's 600 miles across. Thousands of asteroids are known, and dozens of new ones, typically faint and small, are discovered each night. They wander a bit from the ecliptic, and if one gets close to us, it can be seen far from the ecliptic. There are several groups of asteroids, but generally most are between the orbits of Mars and Jupiter. Now, comets can come from any direction, so they can be seen in any part of the sky. Comet Neowise, which was very bright last summer, was best visible in the northern polar section of the sky. Comets generally have a flattened orbit. As they move closer to the sun, they speed up. After they round the sun and head back into deep space, they slow down. Comets that come back within 200 years are known as periodic comets. The others are known as long-period comets. Next week, I'll discuss the sizes of the planets and the amount of time it takes each to go around the sun. Next week, I'll suggest there are a few things that would be helpful to commit to memory. Our observation targets this week are in the same area of our evening sky, halfway up in the east as darkness descends upon the land. One is a double star called Cor Coraea. The other is a galaxy, M94. Both are labeled on Podcast 65, Map 1, and Podcast 65, Map 3. Cor Corelli is a double star in the constellation Canis Venatici below the handle of the Big Dipper. It shines at magnitude 2.8 and is the brightest star in that region. In binoculars and a telescope, you can see its companion 19 arcseconds away. The main star is magnitude 2.8. The companion star is fainter at 5.5 magnitude. They go around each other every 8,000 years. The pair of stars is 110 light years away, and you could fit 10 of our solar systems out to the orbit of Neptune between them. That is, the Sun in the center and the planet Neptune tracing a circle around the Sun. You could fit 10 of these between these two stars. About 3 degrees north of Cor Corelli is a galaxy known as M94. It is about magnitude 8 and is seen face on. But this galaxy's arms are weak, and the center, the core of the galaxy, is bright. It has a high surface brightness, so it stands out well, and we often show this galaxy at public star parties. M94 is about 14 million light years away and is much smaller than our galaxy, which is the Milky Way galaxy. Using Podcast 65, Map 3, try locating and splitting the double star Cor Corelli. The secondary star, that is a fainter star, is only 19 arcseconds away from the primary, but some binoculars have held steady can split this distance and see 2 stars instead of just one. While in the area, try to find M94 in binoculars. It is small and might at first appear as a slightly out of focus star. Dark skies are needed to pick this one up in binoculars. Now, through a telescope, Cor Corelli should be easy to split. Look for the contrasting colors. M94 should also be easy in a telescope. Under good conditions, you might be able to pick up those tiny arms just outside the core. To recap the podcast, what's up this coming week? The moon is solidly in the morning sky, giving us some dark, clear evenings. Look for M94 and see the double star Cor Corelli. You have been listening to Looking Up with Don, podcast episode 65 for March 31st, 2021. I'm Don Machholz. Once again, the related website for this podcast is donmachholz.com. That is spelled DonMachholz.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky, and in our astro class, we'll discuss the planets, how far away each one is, and how long each takes to go around the sun. We'll look at a couple more objects in our evening sky too, and we'll look at a comet in the morning sky. All that and more. Thank you for listening. See the sky this week. I'll see you next week.